Welcome to section 21.7. This is the 215th session of the CISSP exam prep series. In this session, we'll pivot from attacks to the controls that stop them. We'll answer several questions. How does input validation shut down bad input? What is a web application firewall for? How do you keep a database from betraying its data? How do you protect the code itself? And how do you build applications that bend without breaking? Why does this matter beyond the exam? Because these are the safeguards you will actually recommend and audit. Imagine you own application security for a fast-growing fintech. You cannot rewrite every line your developers ship, but you can insist on layered defenses that catch mistakes before attackers do. Knowing how each control works lets you build genuine defense in depth rather than a checklist that looks good but leaks. How does input validation shut down bad input? Input validation is your single most important application defense because so many attacks begin with untrusted input. The strongest form is allow listing, sometimes called whitelisting, where you define exactly what valid input looks like and reject everything else. If a field expects an age, you accept only a small integer in a sensible range. When the valid set is too varied to describe, you fall back to block listing, naming the dangerous patterns to reject instead, though it is easier to slip past. One rule is non-negotiable. Validation must run on the server, never only in the browser, because client-side checks are trivial to bypass. Picture a bouncer who admits only names on the guest list, rather than one who just turns away a few known troublemakers. Why do metacharacters and parameter pollution complicate this? Some characters carry special programmatic power, like quotes, semicolons, and ampersands. And attackers exploit that power to break out of data and into code. The countermeasure is escaping, marking such a character as ordinary so it loses its special meaning. But attackers adapt. Parameter pollution sneaks past filters by sending two values for the same input, betting the platform validates one and executes the other. A firewall that inspects the first copy may wave through the malicious second copy. The lesson is humbling. No single filter is perfect, so you layer controls and keep platforms patched. Think of disarming a trap by taping over its trigger, only for someone to wire in a second hidden trigger. What is a web application firewall for? A web application firewall adds a protective layer in front of your web server. Unlike a network firewall, it works up at the application layer, inspecting the actual content headed to your app. It receives all incoming traffic, applies validation using allow lists or block lists, and blocks malicious requests before they ever reach the server. It does not replace secure coding, since applications still contain flaws when testing falls short or patches lag, but it catches a great deal on the way in. Picture a mailroom that opens and screens every package before it reaches anyone's desk. How do you keep a database from betraying its data? Two ideas matter here. First, defend the queries. Parameterized queries and stored procedures separate code from data. So user input is passed in as a defined value that can never be executed as a command, which neatly defeats injection. Second, defend the data itself. Data minimization is the strongest move. Simply do not collect or keep sensitive data you do not need, because you cannot lose what you never held. Tokenization swaps a real identifier for a random stand-in with a guarded lookup table to reverse it. And hashing replaces a sensitive value with an irreversible fingerprint, made even tougher by salting it with a random value to resist pre-computed cracking. Picture keeping customer secrets in a vault, but better yet, not keeping the ones you never needed at all. How do you protect the code itself? Developers must safeguard how code is created, stored, and delivered. Code signing lets a developer digitally sign their software so users can verify it is authentic and unaltered, though be warned, signing proves origin, not safety, since signed code can still be malicious. Code reuse through third-party libraries and software development kits saves enormous effort, but every borrowed dependency inherits someone else's flaws, so you must track and patch them. Software diversity means avoiding a single point of failure in your source, executables, or compiler. Code repositories centralize source with version control, logging every change and enabling rollback, which supports both collaboration and auditing. And integrity measurement uses hashes to confirm that what reaches production exactly matches what was approved, flagging any tampering. Think of a supply chain where every part is signed, sourced from vetted suppliers, logged, and checked against the blueprint before assembly. How do you build applications that bend without breaking? Resilient design relies on two related properties. Scalability means an application can take on more resources as demand grows, either by beefing up an existing instance, called scaling up, or by adding more instances to a pool, called scaling out. Elasticity goes further and does this automatically, provisioning resources when load rises and releasing them when it falls, which controls both performance and cost. These traits are hallmarks of cloud platforms and a major reason organizations adopt them. Picture a bridge that can add lanes during rush hour and quietly retire them when traffic thins. So let's bring it together. Input validation, done server-side with allow lists, is your frontline defense, reinforced by escaping and layered against tricks like parameter pollution. A web application firewall screens traffic at the application layer before it reaches your server. Databases are protected by parameterized queries and by minimizing, tokenizing, and hashing the data they hold. Code is safeguarded through signing, dependency management, diversity, repositories, and integrity checks. And resilient applications scale and flex with demand. Layer these controls, and a single mistake no longer means a breach. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.